I'm presenting you today a DSL for designing care pathways. I will show you what is it that a care pathway is, but just to give you some context, this work has been done together with a startup called Intimed, which is a Brazilian health tech. We build their innovative software for helping saving lives. So it's our main purpose there is to build software that will actually be used by doctors, and because it will be used by doctors and it will also be will be designed by doctors, we needed a DSL for them. So our team, we have about 30 developers, 8 product owners, 6 user experience engineers. We have 5 modelers that I will talk about. It's a job that we had to create for this because we had a DSL in this project. We also are doing research together with the university. So we were actually born inside the university. So we have about eight students working with us, and we also have medical doctors that are the domain experts, and we have some people for administrative purposes and financial and things like that. So and we both, myself and Flavio, we are the co-founders of this company. My background, as was told before, I come from the model-driven engineering area, and I was actually from academia. I'm still from academia, but I'm more focused now on the let's say the business side of MD. But so what we do there, we have actually been developing many products. Custom software also. We have big companies that come to us, big hospitals that want some specific software, and then we do all that software engineering work, gathering requirements till prototyping the software and actually developing the software and deploying it. So we noticed that when we were customizing these softwares, we could also make some products out of it. So we started developing Medflow, which is the product of us that is concerned with this DSL that I'm going to present you. So what is Medflow? The story behind it is that you have the practitioner back there that is consulting the patient, and he doesn't have the best knowledge from the best guidelines. So you can imagine, for example, the COVID guidelines, the actual guidelines from the Brazilian government nowadays has about 220 pages with flow charts, with many texts, and it's almost impossible for the doctor to have everything up to date. So everything is constantly changing, and he needs this knowledge, and he needs this support from the experts, and also from these guidelines that are almost always described in big PDFs in the internet. So the question that we had was how could we support doctors to have the best knowledge during their practices? So when they are actually face to face with the patient, he knows how to proceed. He knows how to yeah. So we designed Medflow, which is this big suite of of tooling that MedPath is contained in. So MedPath that I'm going to present you is the designer for designing these flow charts, let's say, that are specific for consulting patients. So we also have, beside MedPath, an interpreter that reads MedPath and generates, or not generates, but interpret the care pathways and render screens for the actual practitioner. And the actual practitioner has the best knowledge from the experts on the other side. And we also have a third tool, which is the dashboard that we give to the managers to see everything about a care pathway. So how many are executing, how many patients he had today or during the month. I mean everything about what's happening in the hospital. So as I told you, MedPath is the domain-specific language that models care pathway. So when I was in England, my work there was to detect inconsistencies in these care pathways. So they have a website there that you can access called NICE, which is the National Institute for Healthcare Excellence. They have about, I don't know, maybe the last time I've checked, they had 5,000 care pathways modeled. So they look like this. So doctors don't. So the first thing that we thought was, okay, we already have many languages that model workflows. What do doctors differ from using, for example, BPMN? And the thing is the simplicity. So they, as soon as they see, for example, a gateway, they will just give up of using it. They really like simplicity. So they just wanted boxes and arrows. And we had, for example, to put guards against their will, but put guards in the arrows. So a care pathway looks like that. So you have, it's pretty similar to a BPMN. And then you have the tasks that the doctor has to do, and not only do, but sometimes the system is talking to the doctor, and he has to, for example, to see an information about something. You have, for example, medication referral to other doctors, and we have these variables. And we had to define it formally. So there is a paper from us that defines this formally in order to avoid deadlocks, non-determinism. So we have a formal language for defining this. But so we actually pose this question: okay, why are we using model-based software engineering? Why are we using Sirius? So we needed our first client needed to standardize the way that doctors treated patients. So they wanted this done by actually tested by 6 months. So we had a very few time for testing an approach for standardizing doctors' treatment. So the first thing that came to mind was to use something like OBIO, like Sirius, that we could prototype rapidly and really have an MVP done in less than 2 months. We had a language that we talked to doctors and they could understand. So the first thing that we thought is that, okay, the tool that we are going to use must be very clear, must be very simple to use, and generate something that can be executed and shown to this client. So the main motivation was to have a fast MVP. And why wouldn't we use, for example, tools like Camunda or BPMN? It was to concentrate on what matters. Doctors wanted to have a clean view of what could be done during consultation. So we actually needed to see what was really necessary for having a treatment. So this was more or less our workflow of constructing the language. So we had first a multidisciplinary knowledge exchange. We had like brainstorms with doctors, with nurses, and some requirement analysis, of course. And we started defining the elements of the language, and we actually started the consultations. We see what were the most often actions that doctors did, and we started modeling the elements. I will show you a bit after. So we were already having this initial implementation of the DSL, right? It was parallel to the definition of the elements. And we used to do partial validation. So we worked by examples. So the first care pathway that we constructed was to treat pneumonia. So we only modeled things that concepts that could be that were used by pneumonia. But then after we modeled some infections care pathways that were much more sophisticated, and we needed to put another element. So this validation was really something that got into a loop that we were enhancing our DSL. Actually here we are talking about the domain model actually, and it ended up being something really similar to this. This is an excerpt. So we have a pathway, and this pathway has many elements, and the domain elements can be, for example, information to the doctor, can be a pause, maybe the patient needs to go and make some examinations and come back with the result of these exams. And so we actually pause the care pathway. We have different types of treatment, auxiliary conduct that is formed by a question. So a care pathway will always have questions for the doctor to pose to the patient. So, and a question has a variable attached to it that can be a Boolean, a numeric, a choice. So we did everything in a way that we could extend. So nowadays we have more than these possible responses. We have even images. A doctor can give as a response an image of the patient, for example. So, but this was the initial one, and the one that has in the paper that you can see. So we used Sirius for the concrete syntax. The concrete syntax of this version is very simple, but we are working on an evolution of this one. But this one is really simple. So this is the actual care pathway of the Zika, which is a disease in tropical countries that is very bad. It can harm your newborn. So this is the standardization for the Zika. So we have an initial step that has a question. The doctor has to ask, for example, to the patient if he has neurological complications. So inside this, you have like a score that the doctors go asking some things more accurate to see if the patient responds well or not, and then he has this Boolean, let's say, response if he has or not neurological complications. And then you have to ask if the patient is pregnant. So if the patient is pregnant, she cannot take some medication that if she was not, she could take. And then you have the actual prescription at the end that you give. So this is a very simple care pathway, just for you to have an idea how it looks like. And each of these guards, they can be, for example, an expression. So if I come back here, you have, I don't know if it's in this excerpt, but you have an operand and an operation that you can actually make. You have a logical statement for the guard. So just for you to have a grasp of the size of the protocol. So this is a medium protocol, let's say an average one. The average protocol is that size, and we already developed over 200 protocols, care pathways for patients. So yeah, so this is the concrete syntax and how it looks like. And for the interpretation part of it, we are using a Python stack with the Django framework and the Angular for the front end. And so we needed to export the model that we generate with Sirius, and we needed to make it easier to read in this web-based stack. So what we've done was that we have a translator that takes the model and generates JSON. But these JSON, they are not, they are fragmented. So I have many JSONs for one model. Why did we do this? Because the models were getting really big, and we wanted to make a dynamic in such as each of these tasks is actually a web screen, is a screen in the doctor's system. So we didn't want to load everything from the model. We wanted to have only this information, and then we have a reference to the next step depending on what the doctor chooses. So we download everything. So we separate the model in many different JSONs, and they are loaded on the fly and incrementally. So we have a very nice experience. So this is how the system that the doctor consults looks like. So he has many kinds of variables. So for example, this is a temperature one. You can have a yes or no, for example. You can have also cards that are medications. And as the doctor ticks something or chooses something, we change dynamically the render. Okay, and this one is the dashboard that I talked about. So it's more it's more interesting to the manager, that he can see how many care pathways has been instantiated, the average time of consultation, and which are the most often care pathways, the most often disease. So for example, here in Brazil is pneumonia and influenza. So some of the results that we've been having, so we have more than 200 care pathways modeled with our DSL. So they serve for different purposes, for emergency, for clinics, primary care. And an interesting fact was that when we modeled the COVID-19 protocol, we could put it in production 24 hours after we started modeling with a doctor. So really fast, we could validate it really fast. And the doctors at the end were using it in 24 hours after. So we have nowadays more than 200 hospitals and clinics as clients. We have more than 10 million executions. 10 million, we can say that it's 10 million patients because a patient can go twice and to the, but we have 10 million treatments, let's say, done to these patients. So how Sirius is being used, summing up, we have the expert doctors acquainted with the processes that these guys, they can model with Sirius, but they still leave details as comments, and then we go there. So they tend to be very busy. Medical doctors, they only the ones really passionate with technology go and sit and draw their own models. So because of this, we have many processes engineers. So they come from the production engineering area here in Brazil. And they are responsible to talk to doctors, to model, and actually to validate with doctors what. So, but this is very nice. I don't know how is going in your countries, in France, but we are facing a shortage of developers here in Brazil. There is a huge competition for developers, and having a model-based framework like that, that we can hire specialists from other domains that are not computer scientists or software engineers, is very nice. It's really nice. So some feedback, review, and prospects for this. Sirius actually proved itself a nice fit for rapid construction and evolution of our DSL. Having the care pathways as a document, as a model, with this idea of model as a first-class citizen, it's really nice for us because we can version this care pathway, we can verify them, we can share through all the processes. So having them as a document is really nice for us. So we started the project in 2017. And we believe now we can explore the web capabilities of Sirius. Maybe we haven't got into it, but it's something that it's in our radar. So that's the thing about why didn't we compile? We interpret the models. It's because we needed to easily integrate with the dynamics of what was happening at the hospital. So the interpreter, we have interpreter for cell phones, we have interpreter for legacy systems, SQL based, Oracle based. So we have many different interpreters. So that's why we went into this direction. And something to also to notice is that data storage was really challenging for us. We needed to make this first we needed to make these translations to JSON, and after fragment it, and then all the JSONs we make them be objects for the Django framework, so they are model objects back there. So it was a bit challenging, the data storage part. So some of the publications, the one that really has MedPath is this one from the International Journal of Medical Informatics. We have two others. So we did an automatic verification of these care pathways, checking deadlocks and things like that, non-determinism. And yes, if you have any question about MedPath or anything else, I'm available here.
Okay, thank you, João. Could you give me an idea of the workload, or the time you spend on this project exactly?
We now are going to the fourth year of the project. So we to have the first experience for the doctor to use, it took like 7 months for constructing the interpreter. I can show you perhaps here. So this is a demo version you can find in our website. So if you know Portuguese, you will see the disease's name here. So for example, I don't know, pneumonia. I was talking about it during the presentation. So you have everything. So this was the thing that took more time to construct, of course, the interpretation. But the modeling itself, I would say that in 2 months we had already a very nice and functional DSL. So yes, so it goes dynamically loading things, and you can come back, and no problem, Frederick.
Okay, so, and would it be easy to adapt it to other processes? I mean, reuse the same, basically quite the same code, but for, I don't know, French process or things like that.
Yeah, I think so. If I show you here the domain model, the part that is really specific for the medical domain is below elements. So the elements are the element of, maybe we could have another entity here that would be, for example, for the medical domain, and one other entity, an abstract entity for the, I don't know. I worked together with Thales, for example, or I don't know, army domain, and you can have all the elements together. I think it would be very feasible to adapt it to another domain.
So thanks again, João. It was really a nice presentation and a nice walk. It was a pleasure to have you. Bye.
Thank you very much. Bye-bye.